Hello and welcome to the Tech Lunch Podcast, where we encourage our listeners to learn something new about tech every week. This can range from learning about new and exciting tech applications to the advancements in coding and technology. If you are always learning, you will always be a step above the rest. Take the time during lunch or during a break to listen and learn, kind of like a lunch and learn, but for the ears. This podcast will open the listeners' ears to new and exciting technologies they may have not been privy to in the past. These topics will range from manufacturing technologies to data collection technologies and everything in between. Hello, I'm Nick.
Hey, I'm John.
Hello, I'm Ed.
And, this week we're going to, still kind of roll on to the 3D printing topic that we've been on. Last week we kind of talked about, some of the software, I guess you can talk about. But, really this week we're going to, kind of just, open it up to, hey, you bought this new 3D printer. It came in a box. You put it together, kind of. If you follow the instructions, you still have some extra parts lying around. Now, what do we do with the damn thing? What is the next step? What is step two? I've taken the darn thing out of the box. I put it together. I have a couple leftover screws because if anybody's ever bought anything from IKEA, that's just how it works. IKEA better knows the divorce store. You can't put anything together without getting in an argument. Ed probably is over there agreeing with me because, he's married. He understands. So, now it's kind of, what's the next step?
Yeah, the biggest thing that I've thought about whenever, where did I start or where did I start and where I've come from? First off, you're absolutely right. There are way too many screws. They predicted that I'm going to lose them, and I pretty much did. So don't be worried if you drop a couple. Honestly, putting it together, it's going to be fine. But then we get into the next steps. It's enhancement, or it's, hey, I need to think about what is the reason I got this printer? Like, what's the whole point behind it? You didn't just buy a printer for $200-300 and put these things together. You didn't just go through with 20 minutes to however long it takes you to put together a printer just to let it sit there and gather dust, did you? Like, it's your point, whether it be educational, whether it be operational, or you just want to show a little bit of art or a model, or you're trying to do cosplay. Cosplay is big nowadays. You need to find your idea is pretty much what I'm getting behind. So first off, you need a clear cut. I need to print this item, and then from there it's okay. I need my program, which is free on most sites. I need the program that'll make the computer understand what I want it to do, which is the computer's the motherboard of the printer. Makes sense. From there, I need it to understand the dimensions, right? So G-code, right? So then the G-code, how do I cut that? It comes from these softwares, which most of them come with, let's say, recommended from the manufacturer website. It's open source, and you can download, hey, this is the one that we use. Personally, I prefer Prusa Slicer. It gives me ability to add some certain G codes easier than others. You can control specific temperatures at specific points, but we can get to that later. But it helps with that process. And then you go into Cura and some of the others. Fusion 360 actually is a beautiful thing. If anybody's looked into it, it will give you the ability to create your idea if you have a bit of modeling or 3D like CAD knowledge. But it lets you go from end to end, build the object, create the STL, load or convert it into G code, and then go off. So I guess that's the whole process that you're doing. But then you're implementing that process to whatever. So like if I have a process manufacturing wise, I need to know what my process or my mounts, like a DIN rail or something like that from a PLC. I need to know what I'm trying to do. What's the goal? And then from there, that firmware is most of the time it's proprietary and it's already on that device. But we can kind of get into that a little bit later. I can change any of those pictures and everything on that page. But that could be a whole other whole other day or a whole other podcast there. So As far as that goes, I mean.
Now, when you talk about the slicer and stuff like that, you're talking about upgrades. You're talking about all that stuff. Right? It's really, it's like you're talking about, the whole manufacturing realm and stuff like that. Not buying something and letting it sit. We're not, going to be going out there and buying $180,000 concrete printer to print doghouses. All right. Not really the number one thing that I think about, with 3D printer nowadays. Now you can build the tiny houses out of them. So I guess it's more or less like a human doghouse.
Yeah, if you're trying to live in a tiny house.
Well, the thing is some married people, we need a place to stay when we get in trouble a lot. Yeah. But, so they have their bonuses. But, you start getting into the filament and stuff like that. So would a filament be considered the next step after you buy a 3D printer? Would it be like filament design, deciding what filament you're going to get based on its application? I know we've kind of already covered an episode about filament, but, we need to, want to backtrack a little bit since we're talking about next steps and stuff like that. Are we getting into, like, filament choices and stuff like that? Is that usually a logical next step?
So I want to go back to what John said. So when we're talking slicing, let's break that down. Let's communicate that to someone that doesn't understand what slicing means. So everybody know what Fruit Ninja is, right?
Yeah.
So basically when we're talking slicing, I am taking an object. Say if I have an apple. I'm cutting that object into segments, and those segments are added together with G-code, say for example. Mm-hmm. And then this G-code that we're using, we're taking the G-code and we're saying at some temperature, some speed, some velocity.
Yeah.
At some point, we're making these things, and there are a lot of parameters that's involved with this. Type of material, the heat at which the material has to become from a solid to a liquid, adhesion rate. We're looking at what about environmental things that can cause problems, mechanical issues. So all these things are what you're talking about. So when we're talking filaments, we're not saying, hey, let's rehash the different type of filaments. We're saying, how is that filament affected by these properties or some property being set wrong? Right. Because every STL file that you get from, say, Thingiverse has to be verified. And sometimes you are the verifier. Sometimes you get something from, the internet, and whoa, wait a minute. This STL file is not corresponding to the G code. Right. And we'll go to John and let him explain a little bit more to that.
Yeah. I think that's actually it's a good way to tie in both what me and Nick were saying, because it's heavily detailed. Like your Ender, if you're choosing Ender to start out with, it's a fantastic step in. It's a good price point for a good size, but it starts out with one of those flexi magnetic. Like it's not a great print bed. For me, the natural progression was let me get a glass bed, let me get a PEI magnetic spring steel, because what Nick was talking about, I also had not only the print bed, because that's a part that I'm heating, but the filament in my head. So it's like, okay, I need to understand how this behaves. You've just started. I have no idea that 220 is the temperature. Is it Fahrenheit? Is it Celsius, Kelvin? Like, I have no idea what this is even reading to me. So at that point, I did a buckshot technique. I was like, okay, I'll try these 3-4, right? Let's see what they do. So getting into the slicing, so let's say you've decided on your slicer. I'm just gonna stick with Prusa slicer, maybe Cura, because I've done that a little bit, but I'm just more comfortable with Prusa. I don't want to speak on the others without actually getting my hands into the program. But with Prusa, I can actually create we call it a smart tower or a temperature tower. And that's where we have, and this is also pulled off a repository. We can get into that in a second. He brought up Thingiverse. That's wonderful. It's got one of the biggest, libraries of STL files to use from. And, those STL files don't have to just be for a printer. They could be for an engraver. They could be for a CNC machine. They could be for you to make an engraver or make a CNC machine.
Right.
So like it's got blueprints. Like
Excellent.
there's like no limit there. So like honestly, if you haven't looked at it, you should probably go check it out. But it goes into, I can take this small block that shows me my overhang that runs all my tests. Like, so overhang, it does like a needle point. It does like a bridge where from one point to one, how much can I maintain that integrity before it falls? And you can take that print and you can slice it at, I want to start at 260 degrees Celsius, which Celsius is standard. I mean, it's metric. Most of the stuff's coming from overseas. Not everything is here. I mean, we'd like it to be, but it is what it is. But that you set that, and you can actually you set that temperature to 260. Then you can copy, paste, Control V, Control C, Control V. You can move that up to above that other bed, that other model, and stick it to it, kind of like a Oreo. And you just keep that Oreo going, and you can change that temperature and say 255, and then you put it again 250, and then you put it again 245. You can do smaller increments, but 5 is generally with temperature. If you don't have it enclosed, it's going to be about the same. You're not going to notice a difference. But you do that temperature tower. Honestly, I suggest the temperature tower is the second thing that you print after you level your bed with like a first layer.
So should it be linear or logarithmic?
That's a good question. I mean, honestly, I was going to get into that too because there's fill patterns as well that you think about. So fill patterns, like if I'm doing, let's just go down to the first bed. How does that create, like, let's just say it's a 2D plane. I just want to cover this square, and I want that square to be uniform. It's not easy, but it's your basic print. So what you do is you start that print, and it goes from side to side to side to side to side to side. So you start to think about how you color something in, right? Mm-hmm. That's exactly what's happening. You're coloring that in. In fact,
Color with plastic.
I found something the other day. You can 3D print with like a little pen where it's just like an FDM printer. You feeding in the filament from the back of the pen, and it's correcting any defects from your finished print.
I've seen that. People doing sculptures with those things.
Which that's
and
impressive.
kids are using them too to learn that at learn with 3D printing.
That's impressive. But that kind of takes out the G code part of it, and that kind of just your manual effect. Yeah, freehand. Yeah, that's great actually.
Free draw.
But when you get down to that like you drawing in that G code or visualizing that G code, it's exactly like you coloring in a square yourself. And then you can actually change that pattern to where maybe I want, let's say we cut it into quadrants. Maybe I want top quadrant A to be marked first, and then it goes to C, so like the other corner, opposite corner, so that I can adjust this and make sure it's level. And then it goes into Archimedean curls and things like, or circles, I think it actually is.
Yeah.
So, but that's, I mean, I could talk about this pretty much all day.
That was great.
So,
Yeah, exactly.
yeah,
It's like, when you start thinking about that, you start thinking about, strength properties.
Oh, yeah.
Each different filament and inlay and stuff like that. I've used Cura before, stuff like that, but not to a deep extent. Mm-hmm. But, you start talking about, which filament is the strongest. Well, not really filament, but the inlay is the strongest because your strength is not coming from the filament itself. It's coming from the inlay that you put into it. You can go from 0% inlay, something hollow, something that you're not really going to use.
Like a vase, actually.
Right. The vases and stuff like that, all the way up to, 100% filament. Infill would not recommend that because it's going to take forever to print. However, it's still something that's out there. Yeah. If you think about it, right now, if you want something solid, it's going to be at about a 25 to 50% infill. Now, which, really makes you kind of laugh, is that when you get to the point where you start dealing with like the concrete 3D printers that you're dealing with now for like small houses and stuff like that in big communities that they're using in the military to build their barracks, you have technically, when it prints the walls on both sides of the walls, that's a 0% infill, 100%,
yeah.
But the thing is, the walls themselves are the structural integrity because it's concrete. We're not dealing with plastic. If you did a 0 infill, piece, it's going to collapse. It's going to collapse on top of itself for certain things, unless it is a vase print. If it's a vase print, totally different friggin' atmosphere. Yeah. You start dealing with, different geometric shapes and stuff like that, but that's when you start getting into the slicers and stuff like that, and you start setting that infill, how you want it, to your strength design and stuff like that. And you start moving off of, for example, you have the FreeCAD software online where you can download that and load it right into Cura, right into Prusa Slicer, and take that STL model that you just built that has no G code behind it, throw it into that and generate the G code immediately, and then send it to a printer for that printer to execute. You know, and then there's things out there where you can modify your G code so it automatically auto prints the next one. It's just copy paste, and it will spit out, you know, prints all day long just by modifying the G code inside the slicer.
Yeah. So how does that affected by if I'm using triangles, cubic, or gyros?
So it's actually a good question, because getting into like, I brought it up earlier, Archimedean curls or circles. I can't remember if it's either, but
I think they call it curls. Yeah,
I think it is curls, but I could be wrong. But it is what it is. Regardless of what it's called, it goes in a circle to infill your whatever.
Right.
So I think it's Archimedean chords.
That's what it is. Chords. You're right. Yeah, it's chords. So what it's doing, it's doing a circle though. The path is a circle.
Right.
So what I recommend on those is, let's say I have a bearing, which by the way, I've been printing some things that have been articulating. So why can't I print a bearing that articulates as well? Which got a couple fused together, but it was a try. But you can print these things like a bearing, and it can go circular, and it'll fill those things in such a manner that it speeds up the print. And we actually, something that I really can't even get it out of my head is efficiency that I've been thinking about. And it's, if I do an Archimedean chord and I fill in, let's just say a solid cylinder, let's not even say it's 100%, it's going to create shells inside of itself. It's not going to mix those shells, right?
Right.
But if you do, let's say, a gyroid, or a grid, or a star, a hexagon, whatever your imagination wants, like, there are options for those. You can choose those, and it's going to make or break your print time.
So let me ask you a question. Just to keep your train of thought, just the question for both of you guys. So is it better to print individually and put those pieces together, because bearings are individual?
Right.
It depends on what type of bearing. If I'm using roller ball bearings, or if I'm using, I can either use spears or I can use cylinders, and it's different properties, that axial thrust and things like that.
Right.
But the question is, to continue the question, what's the benefit of printing one solid piece that has everything and I do it at one time? Efficiency, I'm assuming.
Yeah.
And printing those things individually and putting them together.
Yeah. Fluidity of motion. If you think about it.
Yeah, I'll let you start, because
you start dealing with fluidity of motion and stuff like that. It's if you can print all at one piece is always also going to be stronger than two, no matter how you look at it, because you're dealing with joints and stuff like that. Shear factors. You start getting into the higher level shear factor at that point. If you think about it, if we start talking about, especially if you're printing in different pieces, if a single piece, if you think about it, when we go back to the slicer standpoint, you start looking at your infill. That means that infill is continuous. In a continuous motion, your crush factor is less, or it's actually higher. Sorry. Now, when you start dealing with two separate entities, you don't know where that picked up and where that left off. So now you have and also at that joint you have a shear force, especially depending on how it's inlaid. It's either left or right lateral shear force. You don't really have it up and down, unless it's a pinpoint. But your crush factor is completely detrimental at that point. If you start thinking about it, you start talking about like a can. You have like the infill is the liquid inside of it with the top on it. However, once you open that top, now you have crush force. And that's the thing. So that top is technically, it's a single piece print. However, you open that top, and now you have a two piece print. Yeah. So now you have that crush force.
That's an excellent analogy. That's pretty good.
Yeah. This whole time he's been talking, I'm trying to think of one for my. No. I actually got a good analogy too, because fundamentally I agree with Nick. There is some certain aspects that change when you say print them separately versus print them together. I will tell you from experience If it is a lot of items, I suggest you do one at a time. Or batch. Not a full max print bed just because you can. It's a terrible idea. I lost all the filament. So let's just, at any point if one fails, it just kind of drags and removes everything else, and then you got a big spaghetti monster. It's not what you want. So I suggest smaller batches if you do batches. That's just not even thinking articulating pieces. That's just in general.
Right.
But when I think about, he just got me thinking about shear force and the point of printing one piece versus the other, and I do agree. Printing one will be fundamentally stronger than you print the others and put them together, because by printing others and putting them together, you've created fail points. That I'm not saying that they will fail, but you can fail at that point. But if I print it as one piece, I'm just going to take a small example like a toothpick. So you think of a toothpick. When you break the toothpick, you're grabbing it at the middle and you're breaking it down even sides, right? Mm-hmm. When you're looking at that, though, you're breaking that down in one plane, like straight down the middle. So if I hold the toothpick upright, I'm breaking it straight down the middle. Mm-hmm. How hard is it for you to break it from tip to tip and slice that?
It's going to be a lot harder because
a lot harder
because of the construction of the form.
Exactly. Yeah. And that's the point I'm getting to with it. It's just a lot harder because of your layer orientation, as well as how many points of failure you've introduced into there. Now, realistically, you have every layer connecting or touching another layer is a point of failure, if I take it into that sense. But here's a little tip that if anybody is already 3D printing, you might want to do. It's going to mess with some of your dimensions. Take a heat gun, hit it real quick after everything's kind of dried up. Those layers are going to stick together a bit better. It's gonna melt a little, get soft a little bit, and then reconnect to each other. So that's just an idea.
So what do you say to the guy that said, "Hey, bearings are made in pieces"? Just hear me out.
Okay.
Because I understand the limitations of hobbyist printers.
Mm-hmm. Yeah.
And he says, "You know what? And I only have this size, and I want to print it larger than this size. Why can't I just print some of it and make the print to where I can connect the other parts? So like Lego. Why can't I make Lego?
Well,
why can't I construct this thing in parts? And we're not talking about bearings or something like that. Maybe we're just talking something as simple as, hey,
brick walls made a set like in
individual pieces.
Yeah.
Now here's the curveball. It's always a curveball.
Yeah.
So, what about triangles?
Yeah.
Are triangles stronger? Are triangles easier? What if I don't want supports? What if I don't need supports? What about at the end of the print? I want a smooth edge at the end of the print.
We start dealing with supports. You're in a whole different bag animals.
Yeah, it's gonna. Yeah.
And let me. What about the sausages are inside of? Say if I'm printing a frog.
Okay.
There's a structure inside the frog also. I can have supports outside or inside.
Well, see, no, you're absolutely right, because when Nick was talking about building a house and your walls that you're building are 100% infill, absolutely right. But then the inside of the house isn't 100% infill because you got to live there. So like there's multiple things you have to think of too. Yeah, I mean I agree. It's something that I haven't even thought about that much. Is you set those outer lines. I set those outer shells, because I'm pretty sure they're called shells in there as well. So you set your perimeters, and you set, hey, I need 4, 5, 6, 7 outer shells. Right now, there's no way for you to say, I need them to be in the form of a triangle, though. Like, I need it to reinforce itself. It's just laid lines, cleaning up, and in a straight like.
So maybe the motion is triangular, but the actual material itself has no relationship to geometry in the sense of I'm printing triangles, squares, or circles.
Now, I'm going to get on this real quick. I know we're getting down to time here, but if you think about it, there was an article out there the other day that somebody has 3D printed a bridge. Mm-hmm. You talked about an overspan bridge is going across a body of water. Somebody has printed that. If you think about it, the slicer medium that they had to put that in to figure out what the G code was to print the darn thing. is astronomical.
Yeah.
And the thing is that kind of goes into the fact that, people are need to understand that, if you know your dimensions, there's very little limitations that this software has. It's going to spit it out. The only limitation that you have at that point is the software, the hardware that the slicer is running on, that can compute the angles that you need. And the thing is I'll tell you this: if you're 3D printing a bridge, I hate to be the structural designer that had to figure out the shear force of that darn thing, because that alone would be mind-boggling, trying to figure out what the weight is, at the center point of gravity, knowing that okay, if 1,000 people step here, will it give? You're dealing with a 3D printer going over water.
Not even to mention the environmental,
right?
The actual,
right?
The temperature difference.
Yeah. Think about your cure time. Your cure time is absolutely ridiculous. If you're printing the supports also underneath it, and it's one thing. It's like that's where the world of 3D printers are going to. You got the different levels. You're doing it's like I hate to keep bringing up the house thing, but the house thing I think is the next biggest thing on the market right now, because you're using a slicer to develop a house that you would usually do in CAD. Take that, convert it to a G code of some sort. Right. That's used by that. I don't know what they use on those printers, but it's probably just a really modified version of Cura.
It's probably
and it's like what are we using? Oh, it's 1,000 square foot freaking house. I'm building it in Cura. Good luck. And it spits it out in concrete. And there you go. Guess which? Now you got a house. For a quarter of the price that you're going to pay for it anywhere else, depending on if concrete's cheap or not.
Even in just labor, not even thinking materials.
Right, exactly.
Cut costs.
Right. Well, think about this. You said slicing, so is CAD the reverse of slicing?
Yeah, I think so.
Are we building in the reverse? We're deconstructing. Slicing is deconstructing.
Right.
CAD is constructing.
Right.
Yeah.
Yeah, everything's
polygons.
Right.
Everything is polygons. We were talking triangles and blah blah blah.
Everything
it all
really
boils down to polygons.
Everything's a coordinate. Yeah. In the grand scheme of things, everything's a coordinate. Technically, if you think about it, and this is probably gonna send Ed into a tailspin of thoughts here, is why can't I 3D print via GPS?
Why can't you?
Well,
I've got other things.
It's not GPS. Because GPS is not the thing the GPS is saying, I'm here to this point. GPS is, hey, it's a string. Think of GPS as a string.
Right, exactly.
Satellite came over and the string attached from the satellite to that point.
But why can't I use GPS codes as my G code?
You can, but we have to explain. We have to explain what we're talking about when we say we're using GPS as the it's the point, but GPS is not the thing that's doing the
target
work.
marker.
It's not the polygon.
Right.
The polygon is the satellite that's using GPS and constructing that into some algorithm and turning that into a polygon. So basically, I'm taking all the points that I hit with the GPS.
So, and I don't know if you want to.
Well, I mean, first off, why can't we? With the GPS, I think with the GPS is your locating system. I mean, G code isn't anything but where's my nozzle's location at this? Where does it go after this other point? It just goes in this line. Okay, well let me follow that line, and if I could get I think the biggest thing would be exactness to the satellite, because if you're thinking small scale, which simplicity scales, so you should probably try to make it on a prototype or a rapid prototyping level first. But I mean, why not?
You're not getting a 10-digit grid on
the possibilities are just endless. I just think that it's really when we start combining technologies, that's where you start really seeing the innovation, and that's where you really start seeing oh, you mean to tell me I can do a light switch for this sensor over here, that whenever I get my my reading from MQTT, it tells me, hey, temperature too hot, turns off the light, keeps it going. Oh, temperature too low, turn it back on.
And the thing is, that goes back to the slicers and stuff like that, where they're all backwards compatible with each other. Everybody realizes that 3D printing and stuff like that, 3D modeling, is going to be the way of the future, and that's kind of where we're going with this. And I think that we're just on for the long haul here, and hopefully with that hopefully we can at least be of some sort of assistance with that. If there's anything that you need, go ahead and ask us questions about it. And so, I'm going to turn it over to, Ed and John for our final, parting shots. And, hope you all have a good, day, evening, or, whatever time it is. But, and we do want to thank every single person who's, listening to us from across the globe. We definitely highly appreciate that. And, y'all are part of the Vulcan Aura family at this point, for listening in. So, I'll turn it over to Ed for our parting shots.
So you shook the cage so you'll get the monster. So the monster says you thinking in 3 dimensions. Maybe I'm thinking in 10 dimensions. And if I'm thinking in 10 dimensions, then I can do whatever I want to do with 3D printing. And when I say dimensions, I'm not talking about alternate realms or things like that. I'm talking about in relationship to a X, Y, and Z. What if it's an X, Y, and Z, and each of those X, Y, and Z has another frame, a point of frame? Yeah. So for me, that's what I would say where 3D printing would be exciting if we could get past the 3 points or 3 dimensions. And we'll let John close us out today.
Yeah, I mean that's a good point with the dimensions, because you think about robot arms that are moving in separate dimensions. You change that origin and
6 degrees of freedom.
But yeah, so first thing I wanted to say is if you're still listening, then you might have a bit of a problem. You should go check out Thingiverse and find something that's interesting to you. Honestly, if you're trying to get a picture of what this whole 3D printing thing is, you probably have seen it somewhere. But if you can find something that you like, whether it be a Millennium Falcon, whether it be like me, I have a Google Home Mini. I got an R2D2 now in my house. Like, whatever interests you, it doesn't have to make sense to anyone but you. Go find something. Go find something that you want to make, and start from there, and then it'll keep going, I promise. And thanks again to everybody, guys. This is nice to have a platform to push the 3D printing. So,
all right.
Thanks.
Thank you for listening to the Tech at Lunch podcast, where we hope you learned something about tech during your break or during your lunchtime. If you did, please give us a follow to prevent missing future episodes. If you have any ideas or something you want to hear or learn about, please send us a show idea to podcast@vulcanaura.com. Hope you have a good rest of the day and continue learning.